In section 3 of chapter 8, we're going to be solving equations that are now going to have complex solutions. That is to say, I is going to play a factor in your processing. Here are the base level problems that you have done before when solving quadratics, but in the past I said, whenever you get a negative underneath the square root, you can just stop and say no real solution. Now we're going to fill this out, finish this up, because now we know the non-real solution, now that we have an understanding of complex numbers. So first step, for trying to find the x-intercepts, or the zeros, or the roots, all those words mean the same thing. The first step is you set y equal to 0, because if you're trying to find when a quadratic hits the x-axis, all coordinates on the x-axis have one thing in common: the y value is always 0. Next, we want to solve for x. You can solve for x by getting rid, in this example, of the second power and the addition of 16. To solve for x, you do the order of operations, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. You do those in reverse order. So we get rid of addition and subtraction first by subtracting 16 to both sides. You will be left with negative 16 is equal to positive x squared. We then get rid of the square by square rooting both sides, or bringing both sides to the 1/2 power if you like exponent notation. Don't forget your plus or minus symbol, because a square root and a square undo one another. And the square root of negative 16 we now know to be equal to 4i. And that is our complex solutions to the problem for number 1. As a little side note, which you will go into in more lessons in the future, anytime you have a complex solution, they will always, always, always come in pairs. Complex solutions, by default, always have to come in pairs when you're solving equations. You can have 2 complex solutions, you can have 4, you could have 6, you can have 8, you could have 10. You cannot have 1 complex solution. You can't have 3 complex solutions. They always come in pairs, because in order to solve, you're going to have to square root both sides at some point, which means you need a plus or minus, meaning there are always going to be 2. Problem number 2, I have y equals 2x squared plus 18. I'm going to do this one a little faster. Set y equal to 0. I'm going to solve for x by getting rid of the plus 18 by subtracting 18 to both sides. That leaves you with negative 18 equals 2x squared. I got to get rid of multiplication and division next, so I'm going to divide both sides by the positive 2. That leaves me with negative 9 is equal to x squared. I square root both sides to get rid of the second power. Don't forget your plus or minus symbol. That means x is going to be equal to plus or minus the square root of negative 9 is 3i. And then lastly, problem number 3, I wanted to throw in this one. It's a little bit different, but I wanted to throw in a problem of this sort. Set y equal to 0. Still going to be the same process as the others. We're still going to add 18 to the other side. We're going to get 18 equals negative 3x squared. We're going to divide both sides by negative 3 to get rid of that in front of the x. Last step is we're going to get rid of the second power by square rooting both sides, and this is where it's a little bit different, because you cannot square root 6. 6 cannot be pulled out of a radical, not nicely. But you can still simplify this, because it's going to be it's going to be x equals plus or minus I root 6. So just because the number doesn't get pulled out does not mean you stop there. If you have a negative underneath the square root, I still want you to pull out the I. I still want you to represent the complex number as a complex number. If you don't do that, that tells me you do not understand when and where i's are incorporated in these problems, and that is largely what I'm assessing you on. This is more akin to the type of problems that you're largely going to be dealing with in this lesson. The previous page is, there was just a single x. It was x squared, but it was just a single x. What happens when you have a quadratic term, that is to say an x to the second power, and a linear term, x to the first power, that can't combine together through addition or subtraction? then that means you got to rely on two techniques, either the quadratic formula or completing the square. Factoring does not work on these. Factoring works when you have rational solutions. These aren't rational, these are complex. So you cannot use those techniques. The two techniques that you should use, you get to pick, is either the quadratic formula or completing the square. I'm going to do the exact same problem twice. The first time I'm going to use the quadratic formula. Second time I'll do completing the square, just as a little recap of both. For those that have forgotten the quadratic formula, it is x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a, where a is the number in front of your quadratic term, a is the term in front of the x squared, so in this one there's a 1. b is the term, the coefficient in front of the linear portion, so it's going to be a negative 8. And c is the constant at the very end that has no variable next to it that's positive 25. So in this problem, we're going to get x is equal to negative 8 plus or minus the square root of b squared minus 4 times my a value times my c value. And that is all going to be divided by 2 times the a value. Here's a bit of advice. Do not do math in between the original problem and this step. I know all of you could, in your head, tell me that this is just going to turn into a positive 8. Do not do that. Most mistakes that are made on quadratic problems are because they go from the original to the quadratic formula. They do some work, and they do it incorrectly. They might say, instead of negative 8, they just somehow make this a negative 8, or maybe they say negative 8 squared is 16. Problems like that occur. They are less likely to occur if you literally rewrite the formula and just replace the letters with their corresponding values. Just a bit of advice to help avoid common mistakes. Because if it's a mistake that you've made in your head and not on paper, it's much more difficult to catch. So that is going to turn into positive 8 plus or minus the square root of 64 minus 100, all divided by 2. That's going to be equal to 8 plus or minus the square root of negative 36, all divided by 2, which is then equal to 8 plus or minus 6i all over 2. Here's one of the nice things about this topic and complex solutions. At this point on older quadratic formula problems, that's when I told you to split it into two, one where the problem uses the plus sign, one where you use the minus. You don't have to do that for complex solutions because the 8 and the 6i will never combine together through addition and subtraction. So splitting them would only create two of the exact same problem. It wouldn't help you at all. But what would help us is the fact that it's 8 plus or minus 6i, all divided by 2. The 8 and the 6 are both divisible by 2. 8 divided by 2 is 4. 6 divided by 2 is 3. And here are my solutions, the two complex solutions, 4 plus or minus 3i. I'm now going to do the exact same problem. I'm going to use a different technique, completing the square. We're going to get the same answer. It's just a different approach. Again, you get to pick between the two techniques which one you want to employ. I'm not going to test you on either of them. In order to complete the square, set y equal to 0. I'm going to go x squared minus 8x, and I'm going to add some number here, such that the part that I have on the screen right now is going to be factorable into a perfect square. But I can't just add a value into an equation without subtracting that same value. All right, I'm going to draw my little area model with the bottom right portion missing. That area is going to be a square, hence why this is called completing the square. We're going to complete this square by filling in its missing piece. The x squared goes in the top left. These two have to combine to get a negative 8x, but additionally, because I'm saying this has to be a square, these two boxes have to be the same. So you just take that middle term and cut it in half. Therefore, it's going to be x minus 4 times x minus 4. So the part that we are missing in our square is positive 16. That's what goes in these two spots. The entire reason I did that is if I gave you the problem x squared minus 8x plus 16, this would factor into x minus 4 times x minus 4, which is simply the quantity x minus 4 quantity squared. And then the two parts that remain on the outside, that positive 25 and the negative 16, that'll combine together to get me a positive 9. Now I have a new equation that only has a single variable. It just has a single x. It doesn't have two like the first one did. So I can solve this. I can subtract 9 to both sides, leaving me with negative 9 is equal to the quantity of x minus 4 quantity squared. I could then square root both sides. Don't forget the plus or minus. That'll give me plus or minus 3i is equal to x minus 4. Then we add 4 to both sides. And that'll give us our final answer of x is equal to 4 plus or minus 3i. Same answer, different process.